Okay, we're set. Okay, good morning. You're on to MAMU with Jarvis. We're still continuing with our grade 10 experience, and we'll be looking at algebra. We started some work on indices, and we intend to continue from where we stopped. Okay, our textbook of reference is the Essential Mathematics for SS1, and like I've said a couple of times, it's the bomb now. It's one book that is the bomb. You really want to get a strong grasp of concepts, especially when it has to do with mathematics and with a self-learning approach. This is one book I recommend you to have. All right. Now, having said that, let's get down to the business of today. We'll be looking at exercise 4.4 of that textbook, which is a reference textbook for our online program going forward. And then it's found on page 52 of the textbook. So let's start by looking at these questions. So we'll go straight away. Question 1, it says q to the power of 1 over 2. Now, looking at that question, you might think, how do I handle a question like this? Q to the power of 1 over 2. Remember, I told you that the index, the expression of the index as a fraction is the concept of roots. So if I have 1, let's say a raised to the power of 1 over n, this will be the nth root of what? A. So applying that here, the answer will simply be what? The what? Square root of what? Q. If indeed that question is Q. When I saw the question, I was thinking it was 9, but let's work with what we have in the book. It is Q, and so that's about the best way you can express that answer. All right, we'll go to question 2. Question 2 says 16 raised to the power of 1 over 2. 16 raised to the power of 1 over 2. Here, I'm going to take you on something a little different. What's the right word to use now? I've given us a little hint of what is to come. When it comes to indices, I have a different take on the topic. My concept of indices begins with an understanding of something we call prime numbers. Prime numbers. And so you're going to be seeing me using the prime number approach to solving problems. I will not follow some things you see in your textbook. I will use a prime number approach because I have my own target objective in doing that. If you look at 16, 16 will be like 2 multiplied 4 times. Let's experiment. 2 times 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. So you discover that 2 multiplied 4 times will give you what? 16. All raised to the power of what? Half. I will then carry out my multiplication at this level because you already know how to manipulate this rule. This will be 2 raised to the power of what? 4 times 1 over 2. And what does that give you? That will be 2 raised to the power of what? 2. And that answer will be what? 4. Now, there's also another approach students would use. They will say 16 raised to the power of 1 over 2. And students will just say square root of what? 16. Square root of what? 16. I tend to run away from that approach because it defeats the whole aim or essence of indices. It defeats the whole essence of indices. Remember that the concept of indices, the understanding of indices is to play at the level of your what? Index. So while that approach may be correct, it limits you in understanding certain ideas that you need to catch up with in solving problems with indices. So you would notice that when I teach this topic in class, especially when I teach grade 10, this concept, I don't use square roots, cube roots. No, I will more like cause my students to go in this approach. So this is the approach, this is my official approach for this class. The reason is because there are certain things I want you to see by using this approach. But if maybe in the exam you're pressured for want of time and whatever to use the other approach, no problem. But it's better when you approach indices from these aspects or from this perspective so that you have a better take on the context. So that's the answer to question 2. All right, so let's go to question 3. In question 3, what do we have in question 3? In question 3, we have 27b to the power of 3 all raised to the power of 1/3. How do you handle a problem like this? The first thing you need to do is to look at 27. If you observe carefully, 27 is a number whose prime is 3. So 27 is actually 3 multiplied 3 times. Now this is a practice you need to, when you see a number, try to identify what the prime is. So this would be 3 multiplied 3 times, b multiplied 3 times, all raised to the power of what? 1/3. Now you can now treat this power is affecting the individual component of this bracket. So this would be 3 raised to the power of 3 times 1/3. This is b raised to the power of 3 times 1/3. And when you do your relevant calculations, this will give you 3b as your final answer. So that takes care of that question. Now, what about question 4? In question 4, we have that x, y, all raised to the power of 2, all raised to the power of what? 1/2. Notice that the square bracket is used. That's a way we handle maths. If you use this bracket, the next bracket is used, and maybe another type of bracket is used in the process. So, all right, so what you have will be this. Don't bother opening this one. Sometimes you must deal with problems as the need arise. Now this will be xy, all raised to the power of 2 times what? 1/2. These two can deal with themselves, and this will become what? 1. So your final answer becomes what? X, y. Are we seeing that? So let's go to question 5. In question 5, you have 125 raised to the power of 1/3. Your first task is to look for the prime factor of 125. Now, to make this a little easier for you, any number that ends with 5 is divisible by 5. So by way of helping you out, 5 will be the prime factor there. So what do you do next? You test. 5 times 5 will be 25, times another 5 will be what? 125. Let's assume you can't place how many 5s you're going to multiply. So you do that gradually. As you do this gradually, it builds your momentum. Now 5 times 5 times 5 will give you 125. How many 5s have I used? I have used what? 3, which is the context of the concept of indices. That is how many times a particular base is being what? Multiplied. All right. So with that said, this will give you what? 5 to the power of 3, or is the power of 1/3, and that will be what? This can cancel this, and your final answer becomes what? 5. Okay. 6. So let's go to question 6. Now in question 6, we have 169 all raised to the power of 1/2. What is the prime factor of 169? It is 13. So you may need to go back and check yourself out in the context of squares and square roots. So this will be what? 13 raised to the power of 2, or raised to the power of 1/2. This will conveniently cancel this, and your final answer is what? 13. That's for question 6. In question 7, you have 121 all raised to the power of 1/2. What's the prime factor of 121? It is 11 raised to the power of 2, or raised to the power of 1/2. And this can easily cancel out, and that will give you what? 11. What about question 8? In question 8, we have 64 all raised to the power of negative, beautiful, negative 1/3. Remember that I'm building with the context of what? I'm building with the context of prime factors. The prime factor of any even number is 2. So we know that it's going to be 2 multiplied how many times? So you can check. You check. How do you do that? You can do that gradually by saying 64 divided by 2, you get 32. Divided by 2, you get 16. Divided by 2, you get what? 8. Divided by 2, you get 4. Divided by 2, you get 2. Divided by 2, you get what? 1. So count how many 2s you have used. 1, 2, 3, 4, 5, 6. You discover that you have used 6 2s so far. So this will be to the power of 6 or raised to the power of negative 1/3. Now, what do? You cancel 1, 2. 2 times negative 1, you now look at this carefully. Remember that A out here. So this will be 1. We said that if I have A to the power of negative n, it is 1/a raised to the power of n. I hope you have not forgotten that. So please take note of that. That's just to help you remember how this was gotten. And this will now give you what? 1/4, because 2 raised to the power of 2 means that 2 is multiplied what? Twice. And when you deal with that, your final answer becomes what? 1/4. Okay? All right. So that's question 8. Active. Okay, so that's question 8. So let's go to question 9. In question 9, you have 273 raised to the power of 3 or raised to the power of 1/3. So how do you handle that? Very straightforward. This will cancel this. And your final answer will be 273. Question 10. In question 10, you have 225 a raised to the power of 4 or raised to the power of 1/2. Now, in this setup, what is the square root? What 2 numbers will I multiply to get 225? Now, this will give me, this is actually 15 raised to the power of 2, and this will be a raised to the power of 4, everything raised to the power of 1/2. At this point, you treat them individually because this means that it's affecting this and it's also affecting this. Times 1/2, then a raised to the power of 4 times what? 1/2. So what's the outcome? This will go with this. This will go with this. This will go here 1. This will go here what? 2. So I'm going to have 15 a raised to the power of what? 2. So that settles question 11. Question 10. What about question 11? In question 11, I have 125a, 125a, all raised to the power of 3, everything raised to the power of 1/3. I need to look at 125. What's the prime factor of 125? And that is 5. Multiplied what? 3 times. And this will be a raised to the power of 3, all raised to the power of 1/3. The next thing I do is to treat them individually. And that will give you what? 5. And that will give you what? A. So that answer is 5A. Okay. So what about 12? In question 12, we have 64a raised to the power of 6, everything raised to the power of what? Raised to the power of 1/3. This will give us the prime factor of 64 is 2 multiplied 6 times. We've done something like that here before. A raised to the power of 6 raised to the power of 1 over 3. Next thing you do is to treat them individually. So this would be what? We should come down here. 2 raised to the power of 6 times 1 over 3. A raised to the power of 6 times 1 over 3. And what happens at the end of the day? This will go here 1, this will go here 2, this will go here 1, this will go here 2. And what do you have? This will be 2 raised to the power of 2, A raised to the power of what? 2. Now, by implication, 2 raised to the power of 2 is what? 4. So the answer becomes 4A squared. So 4A squared becomes your final answer. All right, we've just cleared question 12, so we go to question 13. Now in question 13, we are told to find this, the square root of A times A. How do we handle a question like that? Quite simple. What is square root of A? Square root of A is what? A raised to the power of half. I've told us before that the concept of square roots or roots means what? The index is what? A fractional index. Anytime you see fractional index, you usually would know that you're talking of what? Roots. So this will be that times what? A to the power of 1. Because A essentially is A ones. So this will give us what? Because we are multiplying, we'll do what to their indices. We're adding them. So this will be A half plus 1. And that will give me A 1 over 2. But we don't write that in indices like that. We write in our index usually in improper fraction. So that will be A raised to the power of what? 3 over 2. 1 over 2 is what? 3 over 2 in improper fraction. So that's for 13. 14. In 14, we have the square root of 5 raised to the power of 4. What is square root in indices? Is what? The index that is what? Half. So that will be equal to 5 raised to the power of 4 times 1 over 2. That's what it means. 2 here 1, 2 here 2. And that will give me 5 to the power of 2, which you can simplify to be what? 25, if you so desire. But this is not the objective. This is the objective. Now, question 15. In question 15, we have that the fourth root of x, raised to the power of 8. So how do you handle a problem like that? This fourth root means x raised to the power of 8 or raised to the power of 1 over 4. Now, when I'm writing like this or writing like this, is the same meaning. The same effect is what it creates. So this will be 4 go here 1, 4 go here 2, and that will be x raised to the power of what? 2. Are we seeing that? Now in question 16, we have 1 over 9 all raised to the power of negative 1 over 2. And I need you to pay attention here, because this is where I'm going to be doing something a little different from what I've been teaching. Please take note of this. In an exam setup, there is no one particular way of solving a problem. The solution you prefer is a function of what you are seeing. How you perceive the problem will determine how you will solve the problem. And that's why it's important when your teachers are solving problems in class, you try to understand why they are going in a particular manner. It's so important that you understand why has he chosen this approach over this approach. If you look at this is a what? A fraction. I remember that I said some time ago that if I have 1, let's watch, over a all raised to the power of let's say negative 1, what happens here is that it will turn. We said that reciprocal has a turning effect on fractions. So if you turn this to become what? A raised to the power of 1. So that's the same approach we're going to use here. It is easier for you. It's always easier to handle whole numbers than to handle fractions. So please watch carefully how I'm going to solve this one. And that's the reason why I'll take out time to solve the problems. Understand why my approach varies per time. For this, it's wise to take care of this negative. And this will make this, it will cause this to turn. It has a turning effect on this number. And you're going to have 9 raised to the power of half. Having done that, the next thing you look at now is you look at 9. What is the prime number of 9? Or prime factor of 9? Is 3. So that will be 3 multiplied how many times? Twice. All raised to the power of 1 over 2. When this cancels out, you have your final answer as what? 3. So that's for question 16. Let's look at question 17. There seems to be a pattern formed here. 1 over 27, all raised to the power of what? All raised to the power of, oh, sorry about that, 1 over 25, all raised to the power of negative half. Let me quickly add again. When you're solving mathematical problems, I always advise my students, you'll be doing yourself a disservice if you solve number 1 and you go to number 25 to solve. No. The reason you're giving exercises, I discovered that clearer now that I teach maths, is that as you move from one exercise, as you move from one question in the exercise to the next, a pattern is shown you. You see the pattern, and it's important for you to observe the pattern and understand what is happening. So if you jump from 1 and go to solve 25, you would have lost series of steps that would have been important for you to solve that other question. Especially for topics like change of subject formula. Those students who have seen me over the years handle concepts like that, you will notice that when I teach in class, I do not leave a question because of the nature of the topic. And that's what is playing out here. As you move from one question to the other, try to find out what basic idea is being passed across to you. It's so important. So now we go back to our problem. Notice that it will turn this one, and that will give me what? 25 raised to the power of half. What is 25? That is what? 5 raised to the power of 2, or raised to the power of what? Half. And your final answer becomes what? 5. Now, in question 18, we have 8 over 125, all raised to the power of negative 1 over 3. 8 over 125, all raised to the power of negative 1 over 3. Now, there's something I call toggle in one of my classes. If I have this, all raised to the power of negative n, for instance, what the negative will do is to turn this content, and I'm going to have this as well, b over a, all raised to the power of what? N. Please take note of that. There is no particular way to solve problems. You just need to look at what you need to do first. Now, this one will give me 125 over 8, all raised to the power of 1 over 3. At this point, what do? Look at 125. What is the prime factor of 125? It's 5. How many times? 3 times. Over prime factor 2. How many times is it multiplied? 3 times. All raised to the power of 1 over 3. The next thing you want to do is to treat them what? Individually. And that will give me what? 5 raised to the power of 3 times 1 over 3, all over 2 raised to the power of 3 times 1 over 3, and that invariably will give you 5 over 2. You can leave your answer as that, because while treating indices, we're not concerned in whether you're going to write your answer in mixed fraction, improper. That's not the focus. The focus is to ensure that the operation having to do with the index is well handled. Right, so that's that for that. Question 19 says what? The cube root of 1 over 27. Now, this will be equal to 1 over 27, all raised to the power of what? 1 over 3. I've established before that the cube root is expressed as a fractional index 1/3. Now, there's also another rule you need to remember here. That's why I love solving problems, because as I solve, I see issues and I deal with them. Just like the one of the professions I love so much is the medical profession. No matter how much you are taught, and that's why so you do what is called internship. You must do practical. You must, because it's in handling practicals that you get a firm understanding of what you've been taught through medical school. So that's the same idea here too. Now, in this setup, see what the observation I'm going to make. Now, 1 raised to the power of anything is 1. Anything at all, whether n is a whole number, whether n is a fraction, once 1 is raised to anything, it is what? 1. It is based on this understanding, I can now write 1/27 raised to the power of what? 1/3. So please take note of this. Some of these rules, we cannot just write them, but as we solve, as we see the problems, we begin to handle them. So what do you have from here? This will now be what? 1/3 raised to the power of 3 times 1/3. Because the prime number, or the prime factor of 27 rather, is 3. How many times will I multiply 3 to get 27? It's 3 times. And that will give us finally our answer as what? 1/3. And that takes care of that problem. Okay, so that's that for question 19. So let's proceed to question 20. So you see that you have lots of practice questions to handle. You have lots of reading to do. Okay, that's for question 19. So what does question 20 offer us? In question 20, we have x raised to the power of 2 or raised to the power of -1/2. Now, in this setup, I would advise you take care of the fractions first. So from here, this will cancel this. Remember that may I not make an assumption? In fractions, when you're multiplying fractions, the numerator cancels out the denominator, or the denominator cancels the numerator. That's the reason why multiplying this fraction, we are canceling like this. So take note of that. So I will not make an assumption. I think everybody's flowing with that. Now that's that. And remember your concept of reciprocal, this becomes 1/x. So you see the rules, like I said in previous videos, it's not important for you, it's not so important to know the rules. It's more important to know how you use them. So how you use the rule become more important than just knowing it. You could know it, but not know how to use it. So you need to know how to use the rules. All right, so that's 20. So we'll go to 21. In question 21, what do we have? We have 1/64 or raised to the power of -2/3. So how do we handle that? This negative will cause a turning effect here, and this will become 64 raised to the power of 2/3. The next thing you need to take off now is, what is the prime factor of what? 64. It is what? 2. Now, I need you also to pay close attention to numbers we are always using. When we keep using a number in a particular way, it's important for you to mark them. And that's what comes with practice. You mark them very well, so that as you're using them from time to time, you get used to them. So this will give you what? 2 raised to the power of 6, or raised to the power of what? 2/3. 3 here 1, 3 here 2. 2 times 2 will give me 2 to the power of what? 4. And 2 to the power of 4 is what? 16. All right, so that's for 21. So 22, we're going to have 16 raised to the power of -1/4. Now, this is a very interesting question. To solve this question, you must convert this to improper fraction. That's the first thing being tested here. Need to change this to what? Improper fraction. So what does that give you? Don't bother about the negative yet. That will give you 16 raised to the power of -5 over 4. 1 times 4, or 4 times 4 will give you 4 plus 1. That is 5 over what? 4. So at this point, what's the next thing you do? You look for the prime factor of 16, and that is 2 multiplied 4 times everything raised to the power of -5 over 4. 4 will conveniently cancel 4, and you'll be left with 2 raised to the power of -5 or -5. Now, at this point, you can now say 1 over 2 raised to the power of what? 5, because the negative here will definitely express that of converting this to fraction. So, or rather, the negative here would turn this. Apply your knowledge of reciprocal. Sorry about that, and that will give you 1 over 32. 2 multiplied 5 times will give you 1 over 32. Right, so that takes care of that, and then so that will take care of that, and so that is that for that question. All right, so that's for question 22. So I'll give us a little time to catch our breath while we'll all right, so we're done with 22. So let's look at 23. In question 23, we have this, the fifth root of 4 raised to the power 2.5. Now, the first thing you need to do is to change. You can have this as this. That's the first thing you need to do. Then you need to change this to a proper fraction. 2.5 means 2.5. And the improper fraction of this will be what? 5 over 2. Just look at what I've done here. So you're going to have this to be what? 4 raised to the power of 5 over 2 times 1 over 5. Please do not work on the base if the problem can be solved at the level of the index. Do not work on the base if the problem can be solved at the level of the index. All right, so this is that. And I'm going to have 4 raised to the power of 1 over 2. At this point, I need to work on this one now. So this will be what? 2 raised to the power of 2 times 1 over 2. Are we together? This to go here 1, this to go here 1. So that will give me what? 2 as my final answer. That's for question 23. Right, so let's go to 24. Now in question 24, what do we have? We have the square root of a squared times the cube root of a to the power of 6 times a. Are we seeing that? So this will be equal to a to the power of 2 times 1 over 2 because of the square root. This will be times a to the power of 6 times 1 over 3 times a to the power of 1. Remember I said that a alone is a to the power of 1. So with that said, this will give you a to the power of 1 times a to the power of 2 times a to the power of 1. I see that. So which invariably will give you a to the power of 1 plus 2 plus 1. And that will be a to the power of what? 4. Are we together? So that's for question 24. All right, so one more question to go. In question 25, we are told that x raised to the power of 2 over 3 divided by what? The cube root of x. So how do you solve a question like this? Very simple. X raised to the power of 2 over 3 divided by x raised to the power. What is the cube root of 3? That's 1 over 3. You do your subtraction. That will be x raised to the power of 2 over 3 minus 1 over 3. 2 over 3 minus 1 over 3 is what? X raised to the power of what? 1 over 3. And you can now write your answer as what? The cube root of x. I hope this morning's class has been helpful, and we've just gone almost halfway of the problems there. I always tell us that it takes two things to do well in maths. You must have an interest for it, and you must be willing to practice. Not even intelligence. You don't need intelligence in maths. It's shocking for me to be saying that, but that's the truth. If you put up an interest and you practice, that's all you need to do well and to become an outstanding mathematician. All right, so MAMU with Jarvis, I'll sign out for this morning and trust you will join me in subsequent classes to boost our knowledge of maths. We're going to spend some time having indices, one of the broadest topics in maths, but I'm trusting that at the end of it, you'll have an experience that is worthwhile. Okay, so thank you.